Hello, today we're going to do chapter 6.1 Congruence. This can be found in the Discovering Mathematics textbook 2A. Alright, so first we will talk about congruent figures. So on the very first part, alright, we actually talk about the Singapore flag. Alright, so can you notice that there are some things that are congruent? So what is the meaning of congruent? Congruent, it means to be exactly the same. So all the lengths are the same, all the angles are the same. So the congruent figures in this case for the flag will be the 5 stars. Alright, so all the stars are congruent. They are exactly the same as each other. Okay, now on the next page, right, what we can see is this. We talk about triangle ABC and PQR. So for congruent figures, what happens here is this, okay? All the corresponding sides will be the same. For example, AB will correspond to PQ. They have the exact same length. AC will correspond to PR. They have the exact same length. BC and QR, they have the exact same length. Not only must the lengths be the same, all the angles must be the same. So in short, right, they are like a photocopy of each other. Okay, so they have the same what I call angles, and they also have the same length of sides. So notice that triangle ABC is congruent. It's not 2 lines but 3 lines to show congruency, and they're congruent to triangle PQR. Okay, please note this, okay, the order of vertices actually does matter. So for example, from A to B to C, alright, so it's A first, B first, C first. The angles must follow. So ABC is congruent to PQ and R. Okay, so for example, if I wrote triangle ABC is congruent to triangle QPR, that will be incorrect because I did not take to mind the order of the vertices. Just to test out whether you understand this idea of order, if let's say I did triangle BAC is congruent to triangle QPR, are they congruent? Is this statement correct? Just take a short moment, think about it. In this case, the order of vertices BAC, I went this way, is congruent with QPR. I also went this way, so this is also correct. So another one I could say is triangle CAB is congruent to triangle RPQ. So this is also a correct statement because the order of vertices is correct. Okay, now I'm on page 154 to determine whether each of the following figures are congruent. So we focus on 1A first. So for 1A, there's a 90 degrees, okay? So if you go and take your ruler, go and measure the length of AC, and you go and measure the length of ED, you will find that they are actually the exact same length. Similarly for DF and BC, okay, you go and measure AB and EF, you'll find that they have the exact same length. So in this case, the angles are also the same if you have to measure using a protractor. So I will say that triangle ABC is congruent to triangle EFD. So once again, be very careful about the order of vertices. Then for B, notice that even though the lengths are the same, like KN is equal to PS, then LM is equal to QR, the angles are not the same because on the left hand side, KLMN, all the angles are actually 90 degrees. Over here, the angles are not 90 degrees. So even though the lengths are the same, they are not congruent figures. Okay, so they are not congruent. Okay, lastly, the two circles, they're the same radius, which means that they will have the same circumference, the area will be the same. So in this case, I say that they are congruent, as they have the same radii. Okay, now we move on to page 161. This is exercise 6.1. I'm just going to skip to give you a few examples. Okay, so I'm going to do questions 1A, B, and C. So they say, explain the figures are congruent. Okay, so first one I say that triangle ABC is congruent to triangle DEF. Why? Because to explain all corresponding lengths are the same, all angles, no, not good, all corresponding angles are the same. Okay, for part B, quite obviously the lengths are not the same, so they are not congruent. Okay, so what I can write for B is they are not congruent, as the corresponding lengths are not the same. Lastly, for this, okay, it's a mirror image, but if you notice, they have the same corresponding angles. For example, these two are right angles, this and the two angles are the same, these two angles are the same. Okay, then for corresponding sides, HK will correspond to LM, same length, HG will correspond to LN, same length, GK will correspond to NM, also same length. So all corresponding lengths are the same, all corresponding angles are the same. Hence, even though it may be a mirror image like this, but in this case, these two triangles are still congruent. So I will say that a triangle GHK is congruent to triangle NLM. As, okay, I don't okay, as, let me just use this, as all corresponding lengths are the same and all corresponding angles are the same as well. Okay, now on page 162, where they ask me to name figures that are congruent. So in this case, you just go to search around. You want to pause the video for a while. Okay, let me just use colors over here. This triangle A and triangle G are congruent, or same corresponding lengths and angles are the same. What else I have? Triangle, no, sorry, half an arrow C, half an arrow E. Okay, finally, what we have, let's choose another color, let's choose purple. Figures B and figures H are congruent. Okay, corresponding lengths are the same, corresponding angles are the same. Now we are on question 3. It's on page 162. Okay, now they say determine whether triangle ABC is congruent to A complement, B complement, C complement. If yes, name the transformation. Okay, so in this case, are they congruent? Yes, they are. Explain your answer. So I think I'll just say, okay, let me just get my black pen out. Say, yes, they are congruent. Okay, so the explanation, okay, is from the before, all corresponding lengths and all. Okay, let me just go and get the explanation for you. It's over here. Okay, all corresponding lengths are the same, all corresponding angles are the same. Okay, so now what's the transformation that has turned a triangle ABC into A complement, B complement, C complement? I think what happens here is it's a mirror image. So what I can say that is there is by a reflection. So this is the transformation that's transformed ABC into A complement, B complement, C complement through a reflection. So there's this line of reflection here. This is reflected to this. Okay, similarly for 3B, Are the two triangles congruent? Sorry, not equal. Yes, they are congruent. All corresponding lengths are the same, and all corresponding angles are the same. So similarly, actually, the answer is actually is by a reflection. If you can't see where the line of reflection is, let me just use the laser pointer. Actually, the line of reflection is here like this. That's why this point is reflected here, B is reflected here, and A is reflected here. So the answers for 3A and 3B are exactly the same. So I shall not write it down twice for you. Okay, now on page 163, and I'm looking at question 6. Okay, so now first and foremost, they're trying to say what is the length of DE. So in this case, since the two triangles are already congruent, okay, so let me use the two here. The two triangles ABC is congruent to triangle DEF. So now straight away, all right, I can say this: the length of DE is equals to length of AB, so it's equals to 4 cm. Similarly, what's the length of FD? So length of FD is equivalent to length of CA is equals to 5 cm. So lastly, we want to find the angle DFE. So I will know that this is 90, this is and this angle here is 90. This angle here is 36.9 degrees. Why? Because congruent triangles, they have the exact same angles. So last but not least, okay, to find angle DFE, wow, take is 180 degrees minus 90 minus 36.9 degrees. Okay, this being the angle sum of triangle. So what I get is 53.1 degrees. Okay, we have come to the last question that I'll present to you on for this 6.1. Okay, so for 6.1, what we have here is this instrument of two equivalent pivoting rods is used to measure the internal diameter of a bottle. The pivot M is the midpoint of the rods. Okay, it's known that ABM, so let me just draw it out for you. ABM, okay, and CDM, they are congruent. Find the internal diameter of the bottle. Okay, so since they are congruent, this is quite a simple thing. So AB will be equals to CD. Okay, just look up there. So it's AB will be equals to CD. So I'll say that AB is equals to CD equals to 7C.